In the first module, we saw that strings are sequences of characters. Now let's look at more general sequences. A list is a sequence of values. So here are two lists. One is a list of numbers and the other is a list of strings. Lists are written with square brackets around it and with commas separating the element. So factors consist of 4 numbers, names consist of 3 strings. Unlike other languages, the type of a list is not necessarily uniform. So we could have a list like this, a mixed list which has a number and then a boolean and then a string. Notation in Python is reasonably consistent. So just like we can extract string values at one position or across a range of positions through a slice, we can extract the same with a list. So the first list has 4 elements, so the positions are 0 to 3. So the value at position 3 is the number 10, the last one. Similarly, if we take the slice 0 to 2 of the list mixed, this consists of the values at position 0 and 1. Remember, the 2 is not included. So we get the sublist 3, true. Just like in strings, we can get the length of a list by using the function len. Lists can contain other lists. So here is a list which has 3 elements. The first and the third, the position 0 and 2, are both lists in themselves. The first list has another list inside it, the list containing 37. And implicitly, the third one also has a sequence inside it, the string hello. So here nested of 0 is a list consisting of 2 followed by the list containing 37. Nested of 1 is 4. If we take nested of 2, then we get the list containing hello. If we step inside that list and we take the 0th element, we get the string itself. And if we then go to the third element of that string, we get the second L. So this is how we go deeper inside a list. We go to the outer index, we get the element from the outer list. Then we take a next index, we go inside that nested list, and so on. We can also do slices like this. For instance, we take a first list, we get the 0th element. Then we take the slice from position 1, that is the list containing 37, up to the list containing 37 because it's 1 to 1. And so we get the list containing 37. Though we did not mention it, you cannot take a position in a string and change its value. Strings are said to be immutable. For lists, however, you can't do this. We can take a list of this form and change the value at position 1 from 4 to 7. So now we have a new list which is actually changed in this way, that the first and the third element are the same, but the second element has become 7. We can also do this deep inside a list. So for instance, we can go inside the first position and change the 37 to a 19 by saying nested of 0, 1, 0 is 19. So this says that lists are mutable unlike strings. Another kind of sequence that is sometimes useful is a tuple. A tuple is written with round brackets and it's very often used for simultaneous assignments. So we can take 3 names and assign them 3 corresponding values like this in one assignment statement. Here age takes the value 23, name takes the string Kamal, and primes takes the list 235. In particular, this also allows us to do an exchange of values without using a temporary variable, which is often used in other programming languages. So here x and y are simultaneously reassigned the old values of y and x. There is no order, so we don't destroy a value accidentally. We can also use tuples to have complex values assigned to a name. For instance, if we want to record the x and y coordinates of a 2-dimensional point, we can do it in this manner. We can say point is 35, 48. And then we can extract the y coordinate, for example, by saying, give me the sequence, the tuple point at the first position. Tuples, however, like strings, are immutable, so I cannot change the y coordinate by assigning point 1 to a new value. This will be an error in Python. So sequences are sometimes mutable, sometimes not. Lists are mutable. Both strings and tuples are immutable. Once you define them, you cannot change them. One important function that we need is generalizes what we use when we have slices in a list or a string is the function range. So range I, j produces a sequence of values from I to j minus 1. Again, if we don't give the first position, it automatically starts from 0. So if we just want the sequence from 0 to j minus 1, range j is the same as range 0j. And if we want a sequence in which we skip values, we can give an increment, a third argument k. So if we say ijk, we get I, then I plus k, then I plus 2k and so on, such that I plus nk stays below j. So So we want to stop with n such that I plus nk is below j, and the next increment I plus n plus 1j will be bigger than or equal to j. What if we want to count down? We just make j negative. For instance, if we say ij minus 1, then we would expect that j is smaller than I. We start with a bigger number and count down to a lower number. So we get I minus 1 and so on. And once again, the rule is we must not reach j or cross it. So in this case, since we are coming from above, we will stop at j plus 1. Now range is not exactly a list. It's a sequence of numbers, but it's not a list. So there is a way to convert it to a list by using the function list. So if we take the range output and put it inside the argument to list, then we will actually get a list. So sometimes if you want to use the output of range as a list, you must remember to do this. This is a general feature in Python that we can take the name of a type like list or int or str, and if the argument is valid for that type, that is, it produces an output which is compatible with the type, we can use it. So for instance, if we take the integer 78 and convert it to a string, we'll get the string consisting of 7 followed by 8. Similarly, if we take the string consisting of 3, 2, 1 as characters and ask it to be converted to an integer, we'll get 321. However, if we give something to this int function which is not an integer, we will get an error. So these type conversions work provided the output of the type is a valid value once we interpret this type in the natural way. So let's look at lists a little more carefully. When we have a list of this form, we can think of it as a function which assigns values to positions. So this is like saying that I have 5 positions numbered 0 to 4, and L actually tells me for each position what is the corresponding value. So L of 0 is 13, L of 1 is 46, L of 2 is 0, and so on. So another way of thinking about this is that 0 to 4 in this case are the arguments to the function, which we will call keys, and the corresponding values at these positions are given by the function L applied to the key. So this allows us to generalize sequences to get something called a dictionary. So a dictionary is like a list, except it allows us to use a more general notion of keys, not just the list of values from 0 to n minus 1, which are the positions. In particular, the key could be a string. So if we want to record the scores of cricketers, for instance, we can use a dictionary and use the name of the cricketer as the key. So we can associate a score with Dhawan, with Pujara, and with Kohli. And this kind of data structure is called a dictionary in Python. What can we use as a key? Well, any immutable value. So we can use a number, we can use a string, we can use a tuple, but we cannot use a list because a list is a mutable value, something that can be assigned subparts in place. We cannot use a dictionary either. So dictionary is also mutable, that is, we can change the value assigned to a key. The way we write a dictionary in Python is to use curly braces, not square brackets. So this is what distinguishes an empty dictionary from an empty list. So if we want to use something as a dictionary, we have to tell Python it's a dictionary by first initializing it to be the empty list, empty dictionary. So remember that the key can be any immutable value, an int, float, bool, string, or tuple, but not a list, not a dictionary. As with lists, we can nest dictionaries. So for instance, we can record the scores of different test matches by having the outer key as the test match and the inner key as the name of the batsman. We can directly assign values to a dictionary. So instead of writing it in this notation, we can actually create a key value list in curly braces. So what we do is we write the key colon the value and separate it by commas. So the first one says that take score and assign it to be the dictionary in which the key Dhawan is associated with value 84. The key Kohli is associated with value 200. In the second version, we have two keys at the outer level, test1, test2, and each of these in turn is a dictionary. The inner one in the first case has Dhawan 84, Kohli 200, and the second one has Dhawan 50. So the main difference between a dictionary and a list is that in a dictionary we can create new keys by just assigning them. So if we have an empty dictionary and then we say D0 equal to 7, then this will implicitly create a key 0 and assign it the value 7. On the other hand, If we have a list which is empty and then we want to create a value at the 0th position, we cannot just do that. We cannot just say L of 0 is 7. We have to use some operation to expand the list. Either we can use concatenation like we use for strings with a plus, or append. There are many built-in list operations. So this is one fundamental difference between dictionaries and lists.